Empezar. Good morning. My name is Ricardo Bedoya, and with group number one in plan design, we're going to present our project that is the evaluation of Cumene production plan using Aspen simulation. First, we have the introduction. For the introduction, we have the Cumene properties that are isopropyl benzene, is also known as the Cumene. Cumene also is the main raw material to produce phenol and acetone. Cumene is an important material for the production of fuels, solvent of paints, and varnishes. Also, Cumene is used to produce, Cumene is produced from the reaction between benzene and propylene. For our production plan, we realize and exhaust research in order to establish a new plant using raw materials for benzene and propylene with propane as an inert, using reactions that are the alkylation of benzene, the alkylation of propylene, and isomerization of the isopropyl benzene. Also, the units present in the plant are our reactor, a flash distillation tank, a benzene distillation column, and a Cumene distillation column for the separation units. And also for project purposes, we use a recycle stream.
Well, my name is Oliver Gonzabay. I want to take you about the safety review regarding about the chemical present in the synthesis of the Cumene. Next slide, please. Well, the Cumene is the principal or the main chemics of the production of the involved of the reaction of the benzene on propylene, but the vapor for the explosive mixture with the air and the vapor is heavier than the air that polymerizes explosively when heated or involved in the fire. The consideration of good explosive guideline levels for decision of the works or level of activity within the facilities of the plant. Next slide, please. The benzene is the main feed or reactant to produce Cumene, but they produce cancer in the blood if released or a lot of time to expose this of the chemics. The layer bone formation in the fetus narrow, damage in the fetus in only high levels can cause dizziness, rapid heart rate, headache, tremors, confusion, and loss of the consciousness. The next slide. Last one, the propylene. Exposure to high concentration causes suffocation with headache. Also, people can affect the weakness, nausea, vomiting, loss of the coordination and movement, passing out, and even death. The limit for the workers, the LV is 500 ppm. Thank you.
Hi, my name is Jefferson Zavaleta. Block flow diagram. For our project, we adapted the BFD from Mahaprata to the project specification. This process contains a reactor and 3 separation units, a flash distillation tank, and 2 distillation columns for benzene and Cumene. The BFD for our project present a recycled stream. The stream living above the flash unit is separated into 2 streams. 17% of this stream is recirculated and mixed with the feed stream. The mixed streams is now the new input for the reactor. The stream leaving the top of the Cumene distillation consign and the product flows in the main objective of this project. Next. Process flows diagram. We use Aspen to generate this PFD of our plant project. As discussion previously, the PFD contains a reactor. The node as R101, a flash unit denoted as TK101, and the 2 distillation column name as T101 and T102. In this PFD, the recycled string is represented with a splitter, where 70% of the string leaving TK101 is mixed with the string one with a mixer. Then this string enters the reactor. With this flow sheet, we began to simulate the plant to obtain the amount of products desired.
Hello, my name is Jose Titusunta, and I'm going to talk about the simulation results. First, we will talk about the equipment operation conditions. First, we have the reactor R101 with a temperature of 360 degrees Celsius, a pressure of 25 Gibbs reactor. Then we have the fresh separator TK101 with a temperature of 92.5 degrees Celsius, a pressure of 1 bar, and the vapor and liquid phases separation. Then we have the benzene distillation tower T101 with a temperature of 90 degrees Celsius, a pressure of 1.75 bar, 20 trays, and a reflux ratio of 0.5. Finally, we have the Cumene distillation tower T102 with a temperature of 90 degrees Celsius, a pressure of 1 bar, 20 trays, and a reflux ratio of 0.9. Now, with the simulation results, I would like to compare the fresh feed that is string 1, which has a mole flow of 100 kilomoles per hour that consists of 80 kilomoles per hour of benzene, 15 kilomoles per hour of propylene, and 5 kilomoles per hour of propane. And the product stream, that is stream number 10, which have an 18.05 kilomoles per hour, which consists of 4.89 kilomoles per hour of benzene, 11.94 kilomoles per hour of cumene, 1.13 kilomoles per hour of MDIPB, and 0.09 kilomoles per hour of PDAPB.
Well, after we performed our simulation, we did an economic analysis using the cap cost tool. First, we established the equipment cost of all of the units that are presented in our plant, beginning with the reactor, also using a mixer, the 2 towers, and a vessel that is approximately our flash unit. Next, we find the total equipment cost, that is 22 million, the land factor cost, that is 105 million. Also, we establish another type of cost, that is the raw material cost, the cost of utilities, and the waste treatment cost and the cost of operating labor are not part of this project. Also, we have the revenue from sales using the amount of product that we obtain in the simulation and the cost found in the bibliography. And finally, we find the cost of manufacturing, that is 27 million. Also, cap cost bring us the cash flow diagram, which is a graphic of the project value and project life. We can see that between the year 0, and year 2, we are going to have losses, but after the second year, we are going to raise. Our project is going to raise, and between the 11th year, the project is going to get profitable. Also, the cap cost brings this table, which is the table for cash flow and cumulative cash flow for discounted and non-discounted.
Well, in conclusion, La Libertad City is the better option to develop this project because together of this, there are the refinery oil La Libertad that produce excellent benzene, propylene to involve in the reaction of the synthesis Cumene. You need to also to consider aspect of the safety because many chemicals present in the synthesis of Cumene are toxic, in special to benzene produce cancer. And regarding of the simulation, high energy spent because needed to keeping the operation of the flash tank and to tower distillation. The project needed 1,700 gigajoules per hour to produce 1,435 kilograms of Cumene per hour. The last one, according to the table extract from the CAPS cost and two graphics developed, this plan will get right number in the first 2 years. However, after the second years, the production will get profitable. Thank you so much for your attention.